This is episode number 690 with Krishna Gade, co-founder and CEO of Fiddler.AI. Welcome back to the Super Data Science Podcast. Today I'm joined by the remarkably well-spoken AI entrepreneur, Krishna Gade. Krishna is co-founder and CEO of Fiddler, an AI observability platform that has raised over $45 million in venture capital to build trust in AI systems. He previously worked as an engineering manager on Facebook's newsfeed, as head of data engineering at Pinterest, and as a software engineer at both Twitter and Microsoft. He holds a master's in computer science from the University of Minnesota. In this episode, Krishna details how the large language models that enable generative AI are prone to inaccurate statements. They can be biased against protected groups, and they're susceptible to exposing private data. He then follows up with how these undesirable and even harmful LLM outputs can be identified and be remedied with open source solutions like the Fiddler Auditor that his team has built and released. All right, let's jump right into our conversation. Krishna, welcome to the Super Data Science Podcast. Thank you for coming on. Where in the world are you calling in from today?
Thank you, John. It's my pleasure to be here. I'm calling in from Sunnyvale, California.
Oh, nice. So at the time of recording, I'm in New York and we're experiencing the worst air conditions in recorded history in New York. So I think in California, you've avoided that craziness, eh?
Yeah, I'm sorry to hear that. We had some employees complain about it yesterday that some of them went outside for a bit and got sick.
Oh,
We had
really?
Yeah, like one of our employees was just out for a few minutes and he developed like a sore throat.
Oh, wow.
But yeah, I mean, we've had these type of things, maybe not as bad as what you're having. I remember a year or a couple of years ago, we had a similar thing. Maybe during the pandemic, I think the sky was all red, and there was like,
Yeah. Yeah, California is that's where it's supposed to be. That's where these things are supposed to happen. It's not supposed to be here in New York.
like,
Um, Yeah, so we met over a year ago at the Insight Partners, which is a big venture capital firm. Um, they held a very, very well run conference called Scale Up AI. I actually understand there's going to be another one coming this autumn. And the Scale Up AI conference had lots of amazing speakers. You were one of them, and I met you kind of having lunch in the speaker room. So we were just sitting there, and then you came back on my radar recently because George Matthew, who is a data and AI specialist investor out of Insight Partners, he had an amazing episode recently, episode number 679. He talked about the AI ML landscape. He talked about the kinds of things you should be doing to start and grow an AI startup successfully. He particularly has a ton of specialization in large language models and generative AI. So, brilliant guest, picked his brain. And after we filmed the episode, I said, "Do you have any recommendations for other guests that should be on this show?" He had one recommendation, Krishna, and that was you.
yeah, George is very kind, and he's obviously an investor in Fiddler, so we have
But yeah, he has a lot of investments, so
there's a
he
lot
could
of
have he
investments
could
as
have
well.
he could have recommended a lot of different people. So I don't think he invited you or suggested that I invite you just because of that investment. And yeah, so you're the CEO and co-founder of Fiddler.AI, one of George's investments at Insight Partners. And the I think I can express the overall mission of Fiddler is to build trust into AI. And a particular topic related to that I'd love to dig into is related to large language models and generative AI systems. So probably most of our listeners have played around with these things. They've seen how crazy and amazing and intuitive conversation with an agent like GPT-4 can be. But I've also talked in a lot of recent episodes about how we can ourselves be using open source starting points and then fine tuning our models to specific tasks to create large language models, really powerful generative AI systems for our clients, maybe for users, just to be able to access them on the open web. And the big risk when we do that kind of thing is that these large language models, because when we're working with GPT-4, they spent 6 months putting guardrails on it to try to minimize people misusing the platform as well as to try to minimize harmful outputs coming out of the platform. Um, and so when I myself am taking an open source option, those guardrails aren't there. So I could be in a huge reputational risk. I have a generative AI company myself, Nebula, and if I were to put into production an LLM where people could be asking questions like, "How can I kill the most people for $1?" or like, "Write me a threatening letter," and then my model does that, that'd be very bad for the reputation of my company. So, yeah, my understanding, Krishna, is that at Fiddler, you've been working on a solution.
Absolutely. We started Fiddler 4.5 years ago with this mission to build trust into AI. And a lot of that inspiration came from my experience working at Facebook on the newsfeed during the Trump elections, pre and post Trump elections,
Mhm.
where the newsfeed algorithms by that time were actually quite complicated. They were not large language models, but they were deep learning models trying to predict the news content on feed. What ad or what news story would you see? So the holy grail that we were chasing at the time is like, why am I seeing this news story, or why am I seeing this ad? And so my team built this tool called Why Am I Seeing This, that exposed these insights around the newsfeed models and made humans understand, the practitioners, the data scientists, ML engineers, but also the non engineering folks like the operations folks, the legal folks, the leadership folks at Facebook. And so that's what really inspired me to start Fiddler, because I sort of saw that eventually machine learning and AI will become first class citizens in the software stack, and they might be across the board from business operations to customer support to marketing to core product use cases. And there is this element of trust that needs to be there between the human and the machine for people to be able to use these AI models with confidence and certainty. And so when you fast forward 4.5 years, we have now an AI observability product that we work with several large customers. Large language models is the new phenomenon that happened in the last 6 to 9 months, right? And with the launch of ChatGPT, every enterprise wants to have some sort of a ChatGPT version, either internally or for their external use cases. We work with large banks and insurance companies where they want to build a policy document chatbot internally. So they can break down all the silos of knowledge and bring all the documents in one place and have a chatting assistant that their analysts can use. Now, the problem with this is that uh, while it's okay for a consumer chatbot like ChatGPT to hallucinate and provide creative responses that users can be forgiving, in an enterprise setting, you want the answers to be accurate, you want the answers to be safe, you want the answers to be non-biased, you want the answers to be not leaking private data to your users. So these are all big concerns that any given enterprise, whether an airlines company or a transportation company, manufacturing company, they all want to address. And so we have been working on this area for a while now, and we've launched this product called Fiddler Auditor. It's an open source tool that our customers can use to assess the robustness aspects of these models. Because one of the big challenges when it comes to working with LLMs is you want to fine tune an LLM. So let's say if I want to use OpenAI or Anthropic or say an open source LLM like Llama, and I want to fine tune it for my data set, what I want to know is what are all the failure scenarios that this LLM will have, the fine-tuned LLM. For example, what percentage of prompts will it actually provide inaccurate responses? What percentage of prompts will provide unsafe responses? So what Fiddler Auditor provides is this capability of almost probing the LLM like a human would probe it. Essentially, it would probe with a lot of counterfactual questions to see what kind of responses it is coming up with and create a robustness scorecard that developers can use. They can actually, share it with their stakeholders, maybe compliance stakeholders, maybe other business stakeholders, to build confidence into how they're fine tuning their LLM, and so that they can get to a point where they can make a decision whether they want to use it in production or not. And so this is a very, very important pre-production validation step that the Fiddler Auditor performs today in the LLM workflow.
Nice. So pre-production, it means we've fine-tuned our model. We think it's, the quality of the results for the particular use cases that we're interested in. We're like, okay, it's good enough. We'd like our users to be using this. But we also want to make sure that, that the answers are accurate, that it's not hallucinating, that answers aren't biased towards one particular demographic group or another, and yeah, and that through things like prompt injection attacks, we're not susceptible with our model to exposing private client data, for example. And so, yeah, so you mentioned that the Fiddler Auditor, this open source tool, very cool. I'll be sure to put that in the show notes so that anyone can try it. And it probes like a human questionnaire to see what kinds of responses come out. You mentioned the use of counterfactuals there. I'm
Yeah,
aware of the idea of counterfactuals in the context of like causality
yeah,
modeling. Yeah, is that?
yeah,
Yeah.
absolutely. Yeah, so it's essentially the same concept that we borrowed from. So hence, it's actually the name of Fiddler actually comes from the same concept as well. So when we built our first product, we were focusing on traditional machine learning models, and we were solving the problem of being able to explain a single prediction. Let's say you have a fraud detection model, and it's taking a bunch of features, maybe the transaction amount, the location of the transaction, the sort of the person who's making the transaction, all of that, and it tries to determine what is the likelihood that this transaction is a fraudulent transaction or not. Now it comes up with a score between 0 and 1, saying that, okay, this fraud score for this transaction is zero point 0.7 or zero point 0.8. Now, the key question that we wanted to answer was, why is it saying that? So in order to build that capability, we sort of probe the model like a human does with a lot of counterfactual inputs. So essentially what we would take is, instead of asking with the same sort of input, like say the location is Sunnyvale and the person was making a transaction of around $1,000 and whatnot, you would try to perturb these inputs, and try to ask a lot of counterfactual questions and see what would the model respond in terms of output. And then you come up with an explanation, with saying that, hey, this is the sensitivity of each of the input on the output. And there's obviously very interesting game theoretic applications around it, like Shapley value, which sort of like try to do it in a more systematic and structured manner, where there are certain axioms that would hold, and they would come up with these attributions that, okay, transaction amount is actually making is transaction 40% likely to be fraud. So it'll come up with these attributions. So we were thinking, how do we do this for a large language model? There are several problems with large language models, right? So with large language models, you don't have the weights file most of the time. It's behind the API, and it's like really large, like run a traditional machine learning model. It's billions or trillions of hyperparameters. Now how do you actually set perimeter controls and build some sort of a human interpretability? And that's when we start to think about extending our idea of fiddling with the model, basically asking counterfactual questions. But what if we take the prompts and try to come up with counterfactual prompts of this? So an example could be, let's say I'm building a healthcare chatbot. I'm an insurance company in the health industry. I want to release a chat assistant for my users so they can ask questions about my health insurance and all kinds of questions. Let's say a simple question could be, what's a well-known soft drink that is expected to increase the human life condition, right, or health of the human life? Now the desire the actual ac- the expected response is, there is no such soft drink that exists. Now, but by slightly asking the question differently, by asking different counterfactual questions, we have run an experiment where we can make text da vinci, which is the OpenAI API,
Mhm.
output responses like water, red wine, orange juice, right? So these are inconsistent responses. They are not accurate. They are not consistent with other responses that the LLM is providing. So by running lots of these, thousands of these counterfactual questions, we can then build a scorecard for that prompt, that, hey, for when you actually slightly change the question, the model is breaking, right, maybe 10% of the time or 20% of the time.
Uh,
Now I can do that exercise for a whole bunch of different prompts and come up with a holistic robustness report that you could use. So this is basically where counterfactuals become very useful, because essentially it's like building trust with a human, right? Imagine, you know I'm a big fan of like investigation, and sort of where sort of investigators are sort of talking to suspects, and they kind of ask the same question in various different ways, right, to try to elicit the truth and try to see if the person is lying or not, right.
Mhm.
And so this is basically the same thing, that in this case it's not the human, it's the large language model, and we are using tools like Fiddler Auditor to probe that, to come up with these counterfactuals.
Nice. So yeah, when I kind of paraphrase back to you this idea earlier of how Fiddler Auditor probes like a human questioner, it is like a human interrogator with the light
Exactly.
shining right in their face.
Exactly.
Um, cool. Yeah. So this makes a lot of sense to me. So these counterfactuals are slight iterations on a prompt to see how often the answer breaks down. So you get the sense of how robust it
Correct.
is. Yeah.
Exactly. And then you can, then once you get the responses, we are building these feedback controls where they can take the response and try to detect different types of issues within those content. So for example, the feedback control could be to detect if the response has unsafe words in it, or if it has unsafe pictures in it, or if it, for example, it's basically mentioning a competitor in that response. You don't want like to go to, let's say, a particular health insurance company, and you ask a question and they mention like some other like competing product, and that's not a good experience that you would want. So you can build a lot of these feedback controls or classifiers that basically look at these responses and say like, hey, for these questions, we are actually providing unsafe responses for users. And similarly, you can assess for bias, toxicity, and all kinds of things. So it provides a rich area to sort of make sure that you're testing all kinds of issues that can happen with an LLM.
Very cool. And then so how does that all get rolled up into a scorecard? So like
Yeah.
what does the scorecard kind of summarize?
Absolutely. So essentially, we are in the industry of, we work with a lot of regulated companies like financial services, banks, insurance companies, where there is actually a process around AI governance, or what we call model risk management. So the process of model risk management is, given a model, you know, can we document all the things that we know about the model? What was the algorithm that we are using? What were the features that were important? What training data that was used for it? What are the failure scenarios of the model? What are the interactions between the features and predictions of the model? So we've been doing that, creating these MRM reports, or model risk management reports, from the beginning. So Fiddler can essentially, if it's the goal for large banks to create a AI validation report or a model governance report during before the pre-production. So similarly, in a case of a large language model, if like an institution like a bank or a regulated company is trying to is thinking of using a large language model, they can use a Fiddler Auditor to create a similar type of report, which will have all these numbers, right? So essentially, it will have, hey, we've tested it against these 1,000 prompts. This is the overall robustness score. These are the 10 percentage of prompts that have failed in terms of providing consistent responses. These are the examples of those prompts, and you can go and look into those responses and you kind of see like what was wrong with them. And then we can provide like, hey, like these are the prompts, these are the percentage of prompts where the chat model actually produce unsafe responses. These are the percentage of prompts where the model produced toxic responses, or there was leakage of private data in it, and all kinds of things. So this is like a audit report that you can then share it with your MRM team, and sort of get them satisfied, because this is a big black box, for even bigger black box than traditional machine learning models. So while a
Yeah.
lot of these regulated companies want to adopt generative AI, they know they have to go past this regulatory sort of supervision, and auditor helps them with that.
For sure. That makes a lot of sense. Yeah, the models are getting absolutely enormous. And yeah, there's so many complex interactions between all the terms. You mentioned earlier having billions or trillions of hyperparameters. I think you meant billions
Yeah.
or trillions of parameters.
Correct, that's right.
Um, and so just to make sure, in case we have
Yeah.
listeners out there that are like,
Right.
whoa, that's
Yeah.
um, nice. So this all makes perfect sense to me. It sounds like a very cool tool, and it's awesome that you've open sourced it. So yeah, Fiddler Auditor. You can check it out on GitHub right now. Beyond the Fiddler Auditor, in terms of the broader mission of Fiddler to build trust into AI, what other kinds of capabilities
Yeah.
or functionality does your company offer?
Yeah, we have an enterprise product that focuses on AI observability, explainability, and bias detection. Our goal is to help companies build trust into AI. And so we have identified several building blocks that are needed to build trust into AI. It starts with like model monitoring, data drift monitoring, data quality monitoring, because at the end of the day, if you're not monitoring models, then you may have create business risk. You may provide suboptimal predictions for your users, sometimes biased decisions for your users. So it's very important for you to monitor. The big USP for Fiddler platform is that our ability to explain these models. So we've invested a lot in explainability techniques to suit different types of models, from tree-based models to neural networks, using Shapley value type techniques, but also produced our own innovative explainability algorithms, which we've received best paper awards at different AI conferences.
Oh,
And so the
cool.
explainability techniques help you do root cause analysis. So when you see a model performance issue in production, you can go and use Fiddler's explainability to pinpoint of what went wrong with those predictions or sets of predictions. So you can figure out what you need to do, whether you need to fix the training data set, or which was a feature engineering issue, or was a model architecture issue. And then the other big piece of responsible AI is to be able to detect bias in it. So Fiddler comes with a lot of out of the box bias metrics for different types of models, like disparate impact, demographic parity, and you can then detect bias not only on one set of predicted attributes but intersections of predicted attributes, where you can say, okay, how is the model doing on African Americans of female that are in a particular zip code, right? So you can come up with the different slices where you can then compute these bias metrics. So all of this put together becomes this AI observability offering, which we've been building in the predictive model space, but now extending into large language models. And the robustness tool that we launched, the AI audit, is a first step to it. And then we are now working on this LLM observability, LLM monitoring, where we can monitor the embeddings of LLM models and compute drift in LLM, and provide continuous monitoring of prompts and responses in production.
Very cool, Krishna. Sounds like you are helping all of us bring LLMs into production circumstances where we can feel safe about using them across the Fiddler auditor that obviously we've detailed a lot here, that allows us to feel comfortable that the model's robust. But then, yeah, you mentioned these other tools, monitoring models in production, explainable AI, bias detection. It all sounds like great work, and no surprise that your company's had the success that it has so far. Krishna, before I let you go, I'd love to hear if you have a book recommendation for us.
Absolutely. So I would probably recommend a book along the lines of what we've just spoken. This is the book there I've read a lot and learned a lot. I think you mentioned causal theory. I'm a big fan of Julia Pearl, and the book
Yeah,
is called The Book of Why. And
yeah.
I really recommend the first chapter for everybody. I think it's mind blowing. It sort of was eye opening for me when I read it like many years ago. Around, it talks about all these counterfactuals and causality, and how do you sort of understand the world, and answer questions, and getting, sort of explain the why behind everything.
Nice. That's a great recommendation. I'm confident that you're not the first guest on the show that's recommended this amazing book. For our listeners that want to check out all of the book recommendations that people have ever made on the show, you can go to superdatascience.com/books. But one thing that you did, Krishna, I've hosted hundreds of guests on the show so far. You did something that I should actually probably start asking for all the time, which is a specific chapter recommendation, because I have one or two guests a week, and so this means like somewhere between 50 and 100 book recommendations, which for most people is going to be intractable on top of their jobs and other responsibilities that they have. But getting a chapter recommendation like Book of Why, Chapter One, that's
Yeah,
brilliant. And it's digestible even for me. So
absolutely.
I'm going to crack into that. Thank you so much for the recommendation, Krishna. All right. So if people want recommendations from you after this show, how should they follow you?
Yeah, they can follow me at on Twitter. So I'm pretty active there. Twitter/Krishna Gade is my account, or they can find me on LinkedIn and follow me or connect me there. Or they can reach out to me at Krishna@Fiddler.AI if you are interested in exploring more about what we do at Fiddler, or looking to find your next big job opportunity, we are hiring at Fiddler, always looking for great engineers, product managers, data scientists. Please feel free to ping us at Krishna@Fiddler.AI.
Nice. All right. Thank you very much for that suggestion as well. Hopefully, you get some great inbound interest, not only for your products, but also for people looking for an amazing company to work with that's growing quickly. All right. Thank you so much for taking the time out of your no doubt very busy day, Krishna, to be on the show. And yeah, we'll catch you again sometime soon.
Oh, it's my pleasure, John. Thank you for having me on the show, and always good to see you again.
Cool. That was a nice and tidy and information dense conversation. In today's episode, Krishna detailed how in enterprise settings, LLMs must be accurate, unbiased, and not susceptible to exposing private client data through prompt injection attacks. And then he talked about how thousands of counterfactuals, slight iterations on a model prompt, enable us to quantify when models are robust and safe, as well as critically when they aren't. All right. That's it for today's episode. Until next time, keep on rocking it out there, folks, and I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.